Let us solve this question from chapter 15, Simple Harmonic Motion and Springs. A vertical spring clock system with a period of 2.3 seconds and a mass of 0.35 seconds is released 40 millimeters below its equilibrium position. So before I proceed to answer the question, I'm going to quickly have a sketch for our system. So this is a spring mass system over here, and then we are told that it is released 40 millimeters before the equilibrium. So I'm going to put this position to be my equilibrium, and then since it is 40 millimeters, I'm going to write 0.04 meters. I'm converting already. So it is below equilibrium, and then it has a mass of 0.35 kg. Okay, so once again it is going up at a speed of 0.12 meters per second. Okay, so I'm going to proceed reading the question. So they are saying that it is released 40 millimeters below its equilibrium position with an initial upward velocity of 0.12 meters per second. For this system, determine the amplitude. So once again, thought process for this question, what am I going to do is say, one thing that I know that my potential energy is given by x squared. So when the spring is fully compressed, or when the spring is fully compressed or stretched, what is happening is that the potential energy will be half k amplitude squared. Okay, in the sense that when the spring is fully compressed or stretched, our x will be equaling to amplitude. Okay, so the next thing that I'm going to do is use conservation of energy. Okay, I'm going to say total energy is conserved, right? Meaning that initially, if I sum the kinetic energy and the potential energy of the spring, they are supposed to give me the total energy. Since the total energy is conserved, okay, and then I know that the total energy is equal to the maximum potential energy that I've already mentioned in the above equation. So I'm going to have my total energy being replaced by my maximum potential energy, and then this is going to give me once again half mass initial square plus the formula for the potential energy of the spring. So here I'm going to write my amplitude is a subject of the formula and multiplied both sides by half, and then I'm going to get this equation here, and then going to divide, or let me just write the final answer, okay, which is mv squared over k plus x squared. Okay, so you can see that we don't have the spring constant, and that is one thing that we're gonna have to find. One formula that you know is that angular frequency is given by square root of k over m, and then we're looking for k here, and I know that omega is given by 2 pi frequency, which is going to be square root of k over m, and then what I'm given there in the question is the period. So I'm going to replace frequency by 1 over period, because I know that frequency is equals to 1 over period. Okay, so frequency is equals to 1 over period, and then the next thing that I'm going to do is square root both sides. I'm going to have 2 pi squared over the period squared is equals to k over m. Okay, and then I multiply both sides. I'm going to have that these 2 should be squared as well. 2 squared pi squared over t squared, okay, multiplied by m equals to k. Okay. But then when you look into my equation here, you'll see that I have 1 over k there, and I want to substitute 1 over k. So I'm going to come back here and take a reciprocal of this, which is going to be 1 over k equals to my period squared divided by 2 squared, which I'm just about going to write as 4, pi squared m. Okay, so now I have my equation for k that I can substitute in the equation for the amplitude that I'm looking for. So I'm going to say square root of t squared m v squared all over 4 pi squared m. Okay, I am just replacing the expression for 1 over k there with this. Okay, I'm just replacing this is what is giving this equation, and then plus x squared. So one thing that you'll notice that the m is cancelling, and if m is cancelling, I remain with the amplitude equals to square root of t squared v squared all over 4 pi squared plus x squared. Okay, so that is v squared, and then I'm going to substitute the values that I'm given above, which is going to be period of 2.3 squared multiplied by the velocity of 0.12 squared, okay, and then divided by 4 pi squared plus our x, which is 0.04. It is squared as well, and then it is going to give me 0.059 meters. So this is the value of our amplitude for this question A. Okay. Now we are going to proceed and answer the other parts of the question. Okay, I'm removing that one so that we can move to question B, which is looking for the angular frequency. So the angular frequency is given by 2 pi f, okay, in which we already know that frequency is 1 over period. Okay, so we're going to say 2 pi over t, and then I'm going to have 2 pi divided by the period of 2.3, which is going to give me an answer of 2.7 per second. Okay, this is my question B, which was looking for the angular frequency. Okay, the next question is C, that is looking for the energy. So this energy is the total energy, okay, which is given by half constant a squared. Okay, but then if you can remember, one thing that we have here, we have the amplitude that we got from the previous question, which was 0.059 meter. One thing that we don't have is k, so but if you can remember from the first question, we said omega is equal to square root of k over m. Okay, what is the value of omega is 2 pi f equals to square root of k over m. Okay, if I take, or maybe let me just keep it being omega. If I take the square root, I'm going to have omega squared equals to k over m, and then I'm going to have omega squared multiplied by m equals to k. Okay, and then I'm going to come here and replace the value of k a squared, and then if you can note from the previous question that I've already calculated my omega d, so I'm going to have 2.7 squared multiplied by the mass, which is 0.35, and then multiplied by the amplitude that I've already got as 0.059, and that is all going to give me 4.6 millijoules. Okay, so this is our C. And then the next question is looking for the spring constant. The next question is looking for the spring constant, and if you look above, we've already got its expression, so it's a matter of substitution, okay, in which our omega was 2.7 squared and then multiplied by the mass of 0.35, and that is going to give me 2.6 Newton per meter. Okay, so that is question D. If I go to solve question E, what are they looking for? They are looking for the initial phase angle, or maybe let me just clear this out. Okay, let me just clear this out. And move to question E. So question E, we are looking for the phase angle, the initial phase angle. So what I understand by initial phase angle is that our t will be 0. They will just but be starting to solve, and what we were given when we were starting to solve is that when this thing was initially released, we're given 40 millimeters. So it means that whatsoever equation might be representing this system when t was 0, I can take it as y of 0 was equals to 0.04 meters. Okay, but then looking at this type of motion, that this is a simple harmonic motion, it means that my equation is in the form of a sine of phi. Okay, it has already been simplified. Why? Because t is 0. Okay, you can first write the equation fully, and then if I fully write the equation, actually here I was supposed to indicate that This is 0. Okay, if I write the equation fully, this will be a sine of omega t plus alpha. I've already answered question F, which want the equation of motion. This is the answer for question F. They just want the general equation there. But then the fact that t is 0 for this question, I'm just going to put omega t as 0 over there. Okay, and then what do I know is that here I have 0.04, but then if you can look here is that this thing is going in the opposite direction. It is going up. I've already cleared my diagram, so I have to put a negative there, and then I'm going to have my amplitude that I found above at 0.0594 equals to sine of phi, and then from there I'm just going to use what did I do here? Okay, it was supposed to be multiplied, and then if I solve for these, I'm just going to get my value in, I want to write it in radians, 5.5 radians. Okay, so this completes this question.